Welcome to Once Upon English.
Have you ever looked up at the night sky and wondered what's really out there? Those tiny dots of light are not just stars. They're worlds, burning, frozen, alive, and waiting to be discovered. Today, you and I are going to leave Earth behind. We'll travel beyond the clouds, beyond the moon, and explore every planet, every mystery, and every secret of our solar system. From the fire of the sun to the frozen edge where sunlight dies. This is not just science. This is a journey through time, beauty, and wonder. So buckle up, because once we start this journey, you'll never look at the sky the same way again. Close your eyes for a moment. Imagine standing outside on a cool, quiet night. The air is still. The world around you is silent. Above you, the sky stretches like a dark ocean filled with glittering lights. Stars. Millions of them. But tonight, you are not just a person looking at the stars. Tonight, you are an explorer. Tonight, you are going on a journey far greater than any trip on Earth. You are leaving your home, your city, your planet. You are about to travel across the solar system. Our spaceship is ready. It stands tall, shining under the moonlight. The engines are waiting. The countdown begins. 5, 4, 3, 2, 1. Lift off. The ground shakes. The engines roar like a thunderstorm. The spaceship rises higher and higher. The Earth becomes smaller and smaller until it looks like a beautiful blue marble floating in black space. Now, we are free. Floating in the universe. The sun glows ahead of us like a golden giant. Our first destination, the heart of the solar system, the sun itself. Look ahead. Do you see it? The sun is not just a ball of light. It is a massive star, so huge that more than 1 million Earths could fit inside it. Its fire burns with unimaginable energy, and without it, life on Earth could never exist. The sun is both beautiful and dangerous. If we get too close, we would burn instantly. The surface of the sun reaches about 5,500 degrees Celsius, 10,000 degrees Fahrenheit. But deep inside, in its core, the temperature is much hotter, more than 15 million degrees Celsius. That is where nuclear fusion happens, the process that gives the sun its power. Can you imagine this? Every second, the sun releases more energy than all the electricity ever used by humans in history. And yet, from Earth, we feel only a tiny fraction of its power. The sun is about 4.6 billion years old. That means it has been burning since long before humans, dinosaurs, or even the Earth itself. Scientists say it still has enough fuel to burn for another 5 billion years. After that, it will change, grow larger, and eventually die. But for now, it is alive and shining, the king of our solar system. What if you could stand on the sun? Of course, no one can. The sun is not solid. It is made of gas. mostly hydrogen and helium. If you tried to land, you would simply fall into burning plasma. You would be destroyed instantly. But let's imagine, if you could somehow survive, you would see giant storms moving across the sun's surface. These storms are called sunspots, dark areas that are cooler than the rest of the sun. Some sunspots are so big that Earth could fit inside them. And sometimes the sun explodes with energy, sending out huge flares of fire called solar flares. These explosions release particles that travel across space. When they reach Earth, they can create something magical. The northern lights. Beautiful colors of green, purple, and red dancing in the sky near the North and South poles. So yes, the sun is dangerous, but it is also the reason our world is alive, green and beautiful. Without it, Earth would be a frozen, dead rock floating in the dark. Now turn around. Look at the Earth from here. From space, Earth looks small, but also very special. A shining blue and white jewel. You can see the oceans, the clouds, the continents. From this distance, there are no borders, no countries. Only one planet, our home. And all of it is powered by the sun. The sunlight warms the oceans, grows the forests, and gives energy to every living thing. But we cannot stay here forever. Our journey has only just begun. The solar system is waiting. Planets, moons, storms, ice, and mysteries beyond imagination. So, explorers, are you ready? Our next stop is the closest planet to the sun, Mercury. Engines on. The spaceship turns. The sun glows behind us, and a small gray world comes into view ahead. Hold tight. We are approaching Mercury. Our spaceship moves faster and faster, leaving the blazing sun behind. Ahead of us, a small gray planet slowly grows larger. At first, it looks like the moon, rocky, dry, and full of craters. But this is not the moon. This is Mercury, the closest planet to the sun. Mercury is tiny. In fact, it is the smallest planet in the solar system. It is even smaller than some of Jupiter's moons. Yet it is fast. Very fast. Mercury races around the sun in just 88 Earth days. That means a year on Mercury is less than 3 months for us. Imagine celebrating your birthday 4 times a year. Let's land for a moment. As we approach the surface, the ground looks scarred and broken, covered with deep craters. These craters were created by space rocks, hitting the planet for billions of years. There are no oceans here, no forests, no atmosphere to protect it. Mercury is silent, empty, and lonely. Step outside carefully. Do you feel it? Actually, you don't, because on Mercury, there is almost no air to breathe. If you removed your helmet, you would not survive even for a second. And the temperatures? They are extreme. During the day, the sun beats down with unbelievable heat, up to 430 degrees Celsius, 800 degrees Fahrenheit. But at night, When the sun sets, the heat disappears into space. The temperature falls to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. That's hotter than an oven by day, colder than Antarctica by night. Mercury is a planet of extremes. Here's something even stranger. A day on Mercury, from one sunrise to the next, lasts 176 Earth days. That means the planet spins very slowly, while it races quickly around the sun. Imagine standing on Mercury's surface. The sun would rise slowly, crawl across the sky, and set again after months. Sometimes, the sun would even appear to move backward in the sky because of Mercury's unusual orbit. Can you picture that? A sunrise that never seems to end, and a sun that changes its mind. Scientists used to think Mercury was boring, but when spacecraft visited, they discovered mysteries. For example, even though Mercury is so close to the sun, there is ice hidden deep inside craters at its poles. How is that possible? Because those craters never see sunlight. They are trapped in eternal shadow, keeping frozen water for billions of years. This means that even in a world of fire and stone, there is a trace of ice. A reminder that the universe is always full of surprises. Our time here is short. Mercury has no air, no water, no life. It is a quiet survivor, a rocky witness of the solar system's violent past. But there is still so much more to see. Back inside the spaceship, we look one last time at Mercury's lonely surface. Then the engines roar again. The little gray planet shrinks behind us as we head toward a brighter, more mysterious world. A world covered in thick clouds, glowing like a golden pearl. Our next stop is Venus, the planet of fire, storms and secrets. Hold tight. The journey continues. As our spaceship speeds away from Mercury, a new world comes into view. At first glance, it looks beautiful, almost like Earth. Bright golden clouds cover the entire planet, glowing under the light of the sun. From space, Venus shines like a jewel. No wonder people call it the morning star and the evening star. But do not be fooled. Venus may look like Earth's twin, but beneath those golden clouds lies a world of fire, storms, and crushing pressure. Venus is both beautiful and deadly. Venus is almost the same size as Earth. Its surface area, its mass, even its gravity are very close to ours. If you stand on Venus, you would feel nearly the same weight as on Earth. For this reason, scientists once thought Venus might be another Earth, maybe with oceans, forests, even life. But when spacecraft visited, the truth was shocking. Venus is not a paradise. It is a hell. Let's land. As our spaceship carefully descends through the clouds, we notice something strange. The sky turns yellow, then orange, then a dark red. The clouds are thick with sulfuric acid. Lightning flashes in the distance. The heat rises. Finally, we touch down. Step outside, if you dare. The air is so thick that it feels like being 900 meters, 3,000 feet, under the ocean on Earth. The pressure would crush you instantly without protection. And the temperature? About 470 degrees Celsius, 880 degrees Fahrenheit. That's hotter than Mercury, even though Venus is farther from the sun. Why? Because Venus is wrapped in a thick atmosphere of carbon dioxide. The gases trap heat in a runaway greenhouse effect. It is like living inside a giant oven. Look around. The land is rocky and cracked. Volcanoes rise on the horizon. In fact, Venus has more volcanoes than any other planet in the solar system. Some may still be active today. The clouds above never clear. The sun cannot be seen directly. Daylight here is dim and orange, like a permanent sunset. And here's something unbelievable. A day on Venus is longer than a year. Yes, you heard that right. Venus spins so slowly that one day, from sunrise to sunrise, lasts 243 Earth days. Meanwhile, it takes only 225 days for Venus to orbit the sun. That means, if you lived here, the sun would rise, crawl across the sky, and set again almost a year later. And there's another twist. Venus spins backward. On Earth, the sun rises in the east and sets in the west. But on Venus, it's the opposite. The sun rises in the west and sets in the east. Could we live on Venus? Not on the surface. The heat, pressure, and acid rain make it impossible. But high above the surface, in the upper clouds, things are different. There, the temperature is cooler. The pressure is gentler. Some scientists believe that in the future, humans might build floating cities in Venus's clouds. Imagine walking through the sky of a planet that shines like a star. Back to our spaceship. As we rise through the thick clouds, we look down one last time at this deadly yet fascinating world. Venus is Earth's twin, but it shows us a warning. What happens when a greenhouse effect goes out of control? Above the clouds, Venus glows softly against the darkness of space. Then, as we fly away, a familiar blue planet comes into view. Oceans, clouds, forests. The only place we know that has life. Our next destination is the most important planet of all. Our home, Earth. Engines on. The spaceship turns. The blue marble grows larger and larger. Soon, we will return. Not to stay, but to understand why Earth is so special in the family of planets. There it is, the most beautiful sight in the universe. A glowing blue and white marble, turning slowly in the endless dark. This is our home. This is Earth. From space, Earth looks calm. Gentle white clouds swirl over deep blue oceans. Brown and green continents shine in the sunlight. A thin, fragile layer of atmosphere glows faintly around the planet, protecting everything below. But don't let its quiet beauty fool you. Earth is not silent. Down there are oceans with waves that roar, mountains that rise into the sky, forests full of life, and cities that never sleep. Earth is alive. As our spaceship comes closer, one thing is clear. Earth is covered with water. About 70% of the surface is ocean. That is why it looks so blue from space. The oceans are more than just water. They are alive. Tiny plankton, schools of fish, enormous whales, all move and dance in the deep. The oceans control the climate, carry storms across the world, and give us the oxygen we breathe. Without them, Earth would be a dry, lifeless rock. And yet, Earth is not only water. The land rises too. Deserts of golden sand, forests like green oceans, snowy mountains that shine like diamonds. What makes Earth different from Mercury or Venus? Why is this planet full of life while the others are dead? The answer is balance. Earth is in the habitable zone, the perfect distance from the sun. Not too hot, not too cold, just right. Water can exist here as liquid, ion, and vapor. The atmosphere is rich in oxygen and nitrogen, gases that allow animals and humans to breathe. Plants and trees use sunlight to create food, and in return, they release oxygen. It is a perfect cycle, a delicate machine that has worked for billions of years. And Earth has something else, a magnetic field. Deep inside, its molten iron core creates invisible shields that protect us from deadly solar radiation. Without this, the sun's power would strip away our atmosphere and destroy life. Earth has not always been the same. Long ago, giant dinosaurs ruled the land. Before that, strange sea creatures swam in the oceans. And before that, Earth itself was just a ball of molten rock. Over billions of years, it has changed again and again, and it is still changing today. Earthquakes move continents. Volcanoes build new land. Glaciers carve valleys. Storms reshape coasts. Earth is alive not only with animals and plants, but also with fire, wind, and water. And then there is us, humans. From high above, we see the lights of cities shining in the night. Tiny sparks of intelligence, technology, and dreams. Humans are part of Earth's story, but also its greatest challenge. We build, we explore, we imagine. But we also cut forests, pollute oceans, and change the climate. Still, Earth remains our only home. There is no other planet in the solar system where we can walk freely under the sky, breathe the air, drink the water, and feel the wind. From our spaceship window, Earth glows with beauty and mystery. It is hard to leave, but our journey must continue. Ahead, in the dark, another red world waits. A world of dust, storms, and ancient secrets. We turn the ship. Engines hum. Earth becomes smaller behind us, but our hearts remain tied to it. Now, we set course for Mars, the red planet. Hold tight. Another adventure is about to begin. There it is, a glowing red dot in the distance. As our spaceship gets closer, the red dot grows into a dusty, desert-like world. This is Mars, the planet of dreams, the planet of stories, the planet where humans hope to set foot one day. From far away, Mars looks small. It is only about half the size of Earth, but up close, it is dramatic, strange, and full of secrets. For thousands of years, humans have looked at this red light in the night sky and wondered, is there life out there? Could we live there? As we land, everything around us is painted red. The soil, the rocks, even the air looks tinted with rusty colors. That is because the surface of Mars is covered with iron oxide. Rust. It gives the planet its famous red glow. The air here is thin, almost empty. If you step outside without a spacesuit, you cannot breathe. The atmosphere is mostly carbon dioxide, and it is 100 times thinner than Earth's. The wind blows, but instead of gentle breezes, it can lift up massive storms. Sometimes these storms cover the entire planet for weeks, filling the sky with dust and turning day into night. Imagine standing on Mars during one of these storms. The ground shaking, the red sky swirling, and the sound of the wind howling like a monster. But Mars is not only dust, it is also home to giants. Look over there, Olympus Mons. It is the largest volcano in the solar system. Taller than 3 Mount Everests stacked on top of each other, it stretches nearly 25 kilometers high. If you stood at the bottom, you could not even see the top, because the curve of the planet would hide it. And not far away is Valles Marineris, a canyon so vast that it makes the Grand Canyon look small. It stretches 4,000 kilometers across Mars, almost the width of the United States. If you were standing inside, the cliffs would rise like giant walls around you, disappearing into the sky. Mars is a world of extremes. The tallest mountains, the deepest canyons, the wildest storms. But the biggest mystery of Mars is water. Billions of years ago, scientists believed Mars had rivers, lakes, maybe even oceans. Today, those waters are gone. But traces remain. Dry riverbeds, frozen ice under the surface, and sometimes even a little frost in the morning. Imagine walking across Mars and finding a frozen lake hidden beneath the soil. Could life once have lived there? Could it still exist deep underground, waiting for us to discover it? We don't know yet. But robotic explorers like Curiosity and Perseverance are searching every day. Now picture this. One day, a rocket lands here. The door opens. A human takes the first step onto the red soil. For the first time in history, Earth has sent life to another planet. Scientists believe humans may build habitats on Mars in the future. It won't be easy. The air is toxic. The nights are freezing, as cold as minus 125 degrees Celsius, minus 195 degrees Fahrenheit. But with technology, greenhouses, and determination, we may turn parts of this world into a second home. Mars is not just a planet. It is a dream a dream of exploration, survival, and discovery. Our spaceship is ready to go. We look one last time at the red desert stretching endlessly under the pink sky. Somewhere, far below the surface, there may still be the secret of life. As we rise, Mars becomes smaller, a lonely red light once again in the black sky. Ahead of us, between Mars and the next great giant, lies a belt of rocks, millions of small worlds orbiting the sun. Our next stop, the asteroid belt, the rocky frontier of the solar system. The asteroid belt, the rocky frontier. The engines slow. Ahead of us, the black emptiness begins to sparkle, not with bright light, but with millions of small glints. Our ship drifts into a strange place, a great ring of rocks and dust circling the sun like a slow, silent river. This is the asteroid belt, the rocky frontier between Mars and Jupiter. At first, it looks like a scene from a movie. Stones close together, danger everywhere. But reality is different. Most asteroids are far apart. Miles of empty space between them. The belt is not a solid wall. It is a vast field of lonely rocks, each one following its own path around the sun. Some are the size of houses, some the size of small cities, and a few are large enough to be called worlds. Among these rocks, a few names stand out. Meet Ceres, the quiet, lonely queen of the belt. She is round, not like other asteroids, and she is big enough to be called a dwarf planet. Her surface is pale and mysterious. Imagine huge, bright spots that shine like salt left behind after water has gone away. Scientists who visited Ceres with a robot ship found these bright places and realized they are signs of ancient or hidden water, a hint that even here, in this cold desert of rocks, water has played a role. Then there is Vesta, a bright, colorful giant among the rocks. Vesta looks more like a tiny planet than a simple rock. Its surface tells a story of fire and collisions, great scars and deep craters from ancient impacts. When our robot explorers landed and looked closely, they found rocks that are like pieces of the solar system's first chapters. The asteroids are time machines. They are old pieces of the early solar system, leftovers from when planets were forming. Long ago, small rocks joined together to make larger bodies. But here, the story changed. The gravity of nearby Jupiter, the great giant, stirred and tugged on the young rocks. Jupiter's power kept them from joining into a full planet. Instead, the pieces stayed small, sometimes crashing into one another, sometimes breaking apart, forming rings of dust and stone. Collisions are common. When two rocks smash together, they create dust and smaller fragments. Some of that dust drifts across the solar system and sometimes falls into Earth's atmosphere. When this happens, we see a bright streak in the sky, a shooting star. If a piece survives the fall and lands on Earth, scientists call it a meteorite. These space rocks are treasures for us. They carry clues about how the solar system began, about what the first materials were like, and sometimes even about water and organic chemicals. Imagine stepping onto a small asteroid. The ground is silent. The sky is black and empty. Your foot pushes the dust, but there is almost no gravity to hold you down. A single jump could take you into a slow, floating arc that would last for minutes. If you throw a pebble, it might never come back. It is a world where walking feels like swimming in slow motion. Some asteroids wear names of heroes and gods. Others keep numbers. Some travel alone. Others move together in families. And beyond the main belt lie more distant rocks. The Trojan asteroids that travel near Jupiter's orbit. And much farther out, the icy worlds of the Kuiper Belt. But for now, the belt is our classroom, a place to learn the solar system's early secrets. We watch the rocks slide by, silver flashes in the dark. Each stone is a story, a small world with a past. Our ship hums softly, instruments buzz, collecting dust, mapping shapes, listening to silent echoes. We take a last look at Ceres, at Vesta, at the endless scatter of stones, and feel the truth of it. The solar system is not a finished project. It is a place of fragments, of collisions, and of slow change. And every fragment has a lesson. Engines warm. We leave the rocky ring behind. Ahead, a new light grows, huge, striped, alive with storms. The greatest of the planets waits for us. Our next stop is the king of the solar system, Jupiter, the storm giant. Hold on tight. The adventure continues. We leave the silent rocks of the asteroid belt behind. At first, space feels empty again, but slowly, ahead of us, a huge, glowing ball begins to rise in the darkness. With every hour of travel, it grows bigger and bigger, until it fills our view like a living world of fire and clouds. This is Jupiter, the giant of the solar system. It is not just big, it is huge. If you put all the other planets together, they would still be smaller than Jupiter alone. Imagine a world so wide that more than 1,300 Earths could fit inside it. But Jupiter is not like Earth. It has no solid ground, no safe land to stand on. Jupiter is made of gas, mostly hydrogen and helium, the same material as the sun. It is like a star that never caught fire. If it had been bigger, it could have become a second sun. Instead, it became the king of the planets. As we come closer, the view is breathtaking. Jupiter's surface is painted with colorful stripes, white, red, brown, and golden bands of clouds. These stripes are giant jet streams, winds that blow around the planet at incredible speeds. They never stop. They never rest. And then we see it. The great red spot. It looks like a giant eye staring at us. This spot is not a mark, but a storm. A storm larger than Earth itself. For at least 400 years, it has been spinning, howling and raging, with winds faster than any hurricane on our planet. Imagine standing inside a storm that never ends. A storm that has lasted longer than all of modern history. That is Jupiter's red spot. Jupiter is also a world of sound. Not sound you can hear with your ears, but radio waves, magnetic energy, and lightning storms that flash across its clouds. Lightning here is so powerful, it could destroy entire cities. The planet's magnetic field is the strongest of all planets. A shield so huge it stretches millions of kilometers into space. But Jupiter's greatest treasures may not be in its clouds, but in the small worlds that circle it. This giant has dozens of moons, more than 90 known so far. And some of these moons are among the most fascinating places in the entire solar system. Io, the fiery moon. Its surface is covered with active volcanoes, spitting fire into space. It is the most volcanic body we know. Imagine a world where mountains explode constantly, painting the sky with fire. Europa, the smooth, icy moon. Beneath its frozen surface lies a hidden ocean. More water than all of Earth's oceans combined. Scientists believe this ocean could be a home for life. Imagine creatures swimming in dark, alien seas under the ice. Ganymede, the giant moon. It is bigger than Mercury, with its own magnetic field and strange patterns of ice and rock. Callisto, the ancient moon, scarred by countless craters, a frozen memory of the early solar system. Each moon is like a separate world, with its own story. Together, they make Jupiter not just a planet, but a whole miniature solar system. As we float past, the size of Jupiter leaves us silent. It is a planet of storms, of power, of moons that may hide secrets of life. We take one last look at the great red spot, still turning, still roaring, and we feel small, tiny travelers in the kingdom of a giant. Engines power up again. Ahead, another beauty glows in the distance. A planet with shining golden rings, elegant and mysterious. Our next stop, Saturn, the Lord of the Rings. We leave Jupiter's storms behind, and the darkness of space surrounds us again. But ahead, something begins to shine. At first, it looks like a glowing disk, pale and golden. As we come closer, the shape becomes clear, a giant planet wrapped in breathtaking rings of light. This is Saturn. If Jupiter is the king of storms, Saturn is the lord of beauty. No other planet captures the imagination like this one. Its rings stretch wide, circling the planet in delicate layers, like the grooves of a record, like cosmic jewelry floating in the dark. Saturn is almost as big as Jupiter, but lighter, softer, less dense. If there were an ocean large enough, Saturn could actually float on water. Like Jupiter, it is made mostly of hydrogen and helium, a gas giant with no solid ground beneath its clouds. The first thing our eyes cannot leave is the rings. They look solid, shining like sheets of glass. But the truth is stranger. Saturn's rings are made of countless small pieces of ice and rock, some as tiny as grains of sand, others as large as houses. Together, they orbit Saturn, billions of sparkling shards, reflecting sunlight and glowing like magic. The rings are divided into several bands, A, B, C, and more, each with gaps and divisions that look like hidden patterns. The most famous is the Cassini division, a wide, dark gap discovered centuries ago, carved by the pull of Saturn's moons. These rings may be young in cosmic terms, perhaps only 100 million years old, and one day they may disappear, falling slowly into the planet. For now, they make Saturn the jewel of the solar system, but Saturn is not only about rings. Like Jupiter, it has a rich family of moons, more than 140 known so far, and some of them are even more mysterious than the rings themselves. Titan, the largest moon, bigger than Mercury. Titan has a thick orange atmosphere, the only moon with air dense enough to breathe, though not safe for humans. On Titan, rivers and lakes flow across the land, but they are not made of water. They are made of liquid methane and ethane, strange seas under an alien sky. Scientists dream of sending submarines to sail those lakes, searching for new chemistry, perhaps even new life. Enceladus, a small moon with a dazzling secret. Its icy surface shines like snow, but beneath lies a hidden ocean. Jets of water shoot from its cracks, spraying ice into space like cosmic fountains. These geysers are signs of warmth and activity below, making Enceladus one of the best places to look for life beyond Earth. Other moons, like Rhea, Iapetus, and Mimas, each tell their own story. Craters, strange colors, and unusual shapes. Saturn itself is a world of storms, too. Near its north pole, there's a giant storm shaped like a perfect hexagon, a six-sided cloud pattern larger than Earth. Imagine flying over a storm shaped like geometry, spinning endlessly at the top of a planet. As we orbit, the view is hypnotic. The rings stretch wide across the black sky. The moons shine like lanterns. Saturn glows golden and calm, yet hides power and mystery within. It feels like a planet out of dreams, too perfect to be real, and yet here it is. Silent, spinning, waiting in the cold. Our ship hums, instruments glowing. We take one last look at the golden rings, knowing we will never forget this sight. Ahead, the solar system grows stranger still. Another giant waits, tilted, pale, and mysterious. Next destination, Uranus, the tilted planet of ice. Uranus, the tilted ice giant. The golden rings of Saturn fade behind us, and space becomes darker and colder. Hours turn into days, and then into weeks. Slowly, far away, a faint blue-green dot appears in the black sky. At first it seems quiet, almost shy. But as we come closer, its secrets reveal themselves. This is Uranus, the tilted planet, the strange ice giant of the solar system. Unlike the roaring beauty of Saturn, Uranus seems calm, almost featureless. Its pale cyan color comes from methane gas in its atmosphere, which absorbs red light and reflects the soft, blue-green hue. It looks smooth, like a giant marble hanging in the dark. But behind that calm face, Uranus hides one of the strangest stories in the solar system. The first mystery is its tilt. While most planets spin with only a small tilt, Uranus rolls on its side. Its axis leans at 98 degrees. Imagine Earth tipped so far over that the North Pole pointed almost directly at the Sun. That is Uranus. Scientists believe that long ago, a massive collision with another planet-sized body knocked Uranus over, leaving it spinning sideways forever. Because of this tilt, Uranus has the most extreme seasons of all planets. Each pole spends 42 years in sunlight and then 42 years in darkness. Imagine living on a world where one summer lasts a lifetime, and one winter lasts just as long. Uranus is not just tilted, it also spins in the opposite direction of most planets. While Earth spins from west to east, Uranus spins from east to west. Everything about this planet whispers, different. Though it looks smooth, Uranus has storms too. Faint cloud bands circle the planet, and in recent years, telescopes have seen bright spots. Storms that appear and disappear quickly, like flashes of hidden power beneath the calm. Like Saturn, Uranus has rings, but they are thin, dark, and difficult to see. They are not bright jewels like Saturn's, but more like faint shadows, circling a shy world. And Uranus has moons, 27 known so far, each named after characters from the plays of Shakespeare and the poems of Alexander Pope. Among them, Miranda, a moon of broken landscapes, with cliffs taller than Mount Everest and strange patchwork terrain, as if it was shattered and rebuilt. Titania and Oberon, the largest, named after fairy royalty. Ariel and Umbriel, smaller, but each with mysterious, icy surfaces. These moons, like the planet they orbit, hold secrets. Some may hide ice, water, and strange chemistry inside. Uranus is far away, cold and lonely. Sunlight here is weak, just a pale glow. Yet, standing in its presence, we feel awe. It reminds us that not every world must be wild and stormy. Some worlds are strange in quiet ways, their mysteries hidden beneath stillness. Our ship circles once, then turns outward. Beyond Uranus, the solar system grows darker still. But another blue world waits, brighter, windier, more violent, the final giant before the edge. Neptune, the windy world of deep blue. Beyond Uranus, the solar system grows colder and lonelier. The sun is now just a bright star in the distance, giving little warmth. But far ahead, a sapphire glow shines in the darkness. Deep, mysterious, and beautiful. This is Neptune, the farthest giant, the restless master of winds. Neptune looks like a jewel of the cosmos, glowing a deep, rich blue. Its color comes from methane in its atmosphere, but the exact shade is still a mystery. Scientists believe unknown chemicals or atmospheric secrets add to its stunning hue. It feels alive, almost like an ocean floating in the sky. But do not be fooled by its calm beauty. Neptune is a world of extremes. Its winds are the fastest in the entire solar system, reaching over 2,000 kilometers per hour. Imagine hurricanes that circle the planet faster than the speed of sound. Storms appear suddenly, whirl with incredible force, and then fade, leaving behind shifting patterns of clouds. Like Jupiter, Neptune once had a great dark spot, a giant storm as large as Earth itself. It was first seen by the Voyager 2 spacecraft in 1989, spinning like a hole in the sky. Years later, it vanished, then reappeared in another location, reminding us that Neptune is unpredictable, always changing. Neptune is not alone. It has faint rings, dark and thin, circling like shadows. And it has 14 known moons, each with its own story. The most famous is Triton, a world unlike any other moon in the solar system. Triton is large, icy, and strange. Unlike most moons, it orbits Neptune backward, in the opposite direction of the planet's rotation. This means Triton was likely captured, stolen from the Kuiper Belt long ago. Its surface is frozen, yet alive. Geysers of nitrogen burst from beneath the ice, shooting plumes high into the thin air. Beneath its crust, an ocean may exist, a hidden sea far from the sun. Neptune's gravity keeps Triton close, but one day, far in the future, Triton may spiral inward and break apart. If that happens, Neptune could gain a spectacular new ring system, brighter and wider than Saturn's. As we circle Neptune, the silence of space feels heavy. Here, almost 4.5 billion kilometers from the Sun, the solar system is reaching its edge. The planets are ending, but the journey is not. Because beyond Neptune lies another frontier, a realm of icy worlds, dwarf planets, and comets. We take one last look at Neptune's deep blue storms, the icy face of Triton, and the faint rings. Then our ship points outward, toward the cold unknown. Next destination, Pluto and the Kuiper Belt, the edge of the solar system. The frozen giants, Uranus, and Neptune. As our ship leaves the fiery drama of Jupiter and Saturn behind, we begin to drift into a colder, quieter, and stranger part of the solar system. The sunlight is weaker here, only a pale glow compared to the warmth near Earth. But what we discover in this frozen frontier is nothing less than astonishing. First, let us meet Uranus, a planet unlike any other. Imagine a giant ball of gas and ice, tilted so far that it actually rolls around the sun on its side. While other planets spin like tops, Uranus is like a barrel rolling in space. This bizarre tilt gives Uranus extreme seasons, each lasting more than 20 years. For 2 decades, one pole is bathed in continuous sunlight, while the other pole remains in freezing darkness. Then, they switch. The planet itself is a beautiful pale blue, colored by methane gas in its atmosphere. But don't be fooled by its calm look. Uranus is full of mystery. Beneath its icy clouds lies a strange ocean, not made of water, but of hot, slushy materials under incredible pressure. Some scientists even believe that diamonds could be raining deep inside Uranus. Imagine diamonds falling like raindrops into endless oceans of ice. But Uranus has more secrets. It is surrounded by faint rings, dark and shadowy, unlike the bright rings of Saturn. It also has 27 known moons, each with its own strange personality. For example, Miranda, one of its moons, looks like it has been broken apart and glued back together. Giant cliffs, some taller than Mount Everest, cut across its surface. One leap from the top of these cliffs would send you falling for 10 minutes before hitting the ground. And then, beyond Uranus, we reach the last known planet of our solar system, Neptune. Neptune is the farthest planet from the Sun, and it is a world of deep, rich blue. It is similar to Uranus in many ways, but it is wilder, more violent, and more alive. Winds on Neptune are the fastest in the solar system, racing at over 2,000 kilometers per hour. That's faster than the speed of sound. Imagine standing on Neptune, if you could, and watching storms the size of Earth swirling through its atmosphere. Neptune also has its own system of moons, the largest of which is Triton. Triton is no ordinary moon. It orbits Neptune backward, opposite to the planet's rotation, a sign that it may have been a wandering object captured long ago. And Triton is alive, geologically speaking. It has geysers that shoot ice and gas into space, making it one of the most dynamic moons in the solar system. Here, on the edge of the solar system, the sun is just a bright star in the distance. Yet, even in this cold, dark frontier, there is beauty, motion, and mystery. Uranus and Neptune remind us that our solar system is not only about warmth and life, but also about the strange and the extreme. But wait, the story does not end here. Beyond Neptune lies a vast, shadowy region filled with countless icy bodies. Some call it the solar system's frontier. This is where the dwarf planets live, including the famous Pluto. And this is where we go next. Pluto and the edge of the solar system. We have now arrived at the outer frontier of our solar system, a place so far from the sun that daylight feels like twilight. Here, in this frozen darkness, we meet worlds that are small, distant, and mysterious. The most famous of them all is Pluto. Pluto was once called the ninth planet, but in 2006, it was reclassified as a dwarf planet. Yet, this change did not make Pluto less fascinating. In fact, Pluto is one of the most surprising and beautiful worlds we have ever explored. Pluto's surface is covered in ice, nitrogen ice, methane ice, and even carbon monoxide ice. But it is not a dead world. When the New Horizons spacecraft flew past Pluto in 2015, it revealed a landscape full of mountains made of water ice, plains that look like frozen seas, and glaciers that slowly creep across its surface. One giant heart-shaped plain called Tombaugh Regio became the symbol of Pluto's charm. And Pluto is not alone. It has 5 known moons, the largest of which is Charon. Charon is so big compared to Pluto that together they form a kind of double world, orbiting around a point between them. On Charon, you would see Pluto hanging in the sky, massive and majestic, never setting. But Pluto is only one member of a much larger family. Beyond it lies the Kuiper Belt, a vast region filled with countless icy bodies. Some of these objects are even bigger than Pluto, and many remain undiscovered. This region is like a cosmic treasure chest, holding secrets about the early days of our solar system. And beyond the Kuiper Belt, even farther, lies the mysterious Oort cloud, a gigantic sphere of icy objects that surrounds our solar system like a shell. It is from here that long-period comets are born, falling inward toward the sun, carrying with them ancient material from the dawn of time. Here, at the edge of the solar system, the sun is nothing more than a bright star among billions. Standing here, you can truly feel how small we are and how endless the universe really is. But our story cannot end with just cold numbers or frozen rocks. The solar system is more than a collection of planets and moons. It is a living story. A story of fire and ice, of storms and silence, of endless beauty and mystery. The grand finale, a journey beyond. And so, our incredible voyage through the solar system comes to an end. We began at the blazing heart, the sun, a star so powerful that it gives life to everything we know. We soared past the tiny, scorched world of Mercury, the glowing beauty of Venus, and the precious blue jewel called Earth, our only home. We crossed the dusty deserts of Mars, then marveled at the giant storms of Jupiter and the golden rings of Saturn. We drifted through the icy, tilted mystery of Uranus and battled the fierce winds of Neptune. Finally, we stood at the frozen frontier with Pluto and the countless worlds of the Kuiper Belt. But here is the truth. Even though our tour has ended, the story of the solar system is far from over. Every planet, every moon, every comet is still moving, still changing, still writing new chapters in the greatest book of all, the universe itself. Think about this. We live on a small planet, circling an ordinary star, in one corner of one galaxy among billions. Yet from this tiny place, humans have dreamed, built, and reached for the stars. We have sent spacecraft to touch other worlds, and telescopes to look into the birth of time itself. The solar system is not just out there, it is part of us. Every atom in your body was born in the heart of a star. You are, in a very real way, made of stardust. So, what does this journey teach us? that our world is precious, that curiosity is powerful, and that the universe is endless, waiting for us to explore. As we leave the edge of the solar system and look back one last time, we see it all at once. The sun shining like a golden lantern, the planets dancing around it, the moons orbiting their worlds, the comets tracing their icy paths. It is not just a system of planets, it is a cosmic symphony, a masterpiece written in light and motion. And perhaps the most exciting part is this: our journey has only just begun. Because one day, humans will travel farther. One day, we may stand on Mars, sail through the rings of Saturn, or walk on the frozen plains of Pluto. One day, we may leave the solar system itself, carrying the story of Earth to the stars. Until then, we can look up at the night sky, see those tiny points of light, and know that we are part of something far greater than ourselves. The solar system is not just our neighborhood in space. It is our story, our past, our future. And it is waiting for us to keep exploring. Our journey through the solar system has come to an end, but the adventure of learning never stops. If you enjoyed traveling among the stars with me today, don't forget to give this video a thumbs up and subscribe to the channel. That way, you'll never miss our next cosmic adventure. Together, we'll keep exploring, keep dreaming, and keep reaching for the stars. See you in the next journey.